Private data storage is one of the main reasons I started my kube-homelab project, which is a Raspberry Pi which runs a Kubernetes cluster and allows me to use private workloads on my home network. In this video, I'll show you how I've set it up and how I access that storage within my Kubernetes cluster with an open source project called as OpenEBS and persistent volumes in Kubernetes. Let's get started. Okay, let's see how I've set this up. The first thing that I'm going to show you is the hardware requirements themselves. I have a hard drive that I want to use to store all my data. So if I SSH into the Pi, what I've done is I've added the hard drive to be mounted on boot via this line in the FS tab. So I'm using the partition UUID and then specifying the path where I want to mount this. So I want to make sure that I can sort of add more drives going forward. So that's the naming convention that I've followed. So this is the base path, and inside this I'm going to create one folder per drive. So what that means is whenever this Pi reboots, but in case there's a power outage, even though I have power backup set up, in case the Pi does reboot, I can be sure that the hard drive is available at this path. So that's the base path that I'm going to work with. So as you can see, there are a couple of folders that I've created here, one of them being the actual files that I'm going to store. So there are going to be things like documents, photos that I want to share. App data is going to create a folder where each application that requires any sort of persistence is going to have one folder within it. So for example, if I show you, one of them is Postgres. So there's a folder for that. And any app going forward, if it wants to store any data, I want to create one folder for each of them. So that's the hardware setup. And now I have a folder where I can keep all my data. The way this comes into the Kubernetes cluster is I use a project called as OpenEBS. And all of this is again in the same cluster resources molecule. If you're not entirely sure about what these molecules are, I've explained those in the previous video on Homelab series part 2. So be sure to check that out. So on the Homelabs cluster resources molecule, what I've done is I've added this OpenEBS Helm chart, and I've also passed in this values.yml. OpenEBS comes with a lot of provisioners that you could use. The one that I am interested in is the local provisioner. It allows me to pass in a base path, and that then uses host path to sort of create all the persistent volumes. And if you see, I've passed in my base path, but one thing that you will realize is because this base path is specific to one node in your Kubernetes cluster, all the persistent volumes are supposed to be created with the same node affinity. In my setup, I only have one node, but I can show you the setup on how this is being used while creating the persistent volume. So now OpenEBS has a folder that it can use to store all of the data, and internally it just uses the hard drive that I've connected, but OpenEBS has no idea about what sort of hardware it's using because it's all abstracted away. And what it knows is it has a folder where it can store that data. So now let's take a look at one of the applications that uses OpenEBS to store its data. And this application is called OnCloud. So OnCloud is an application to help you share files and folders. And the way I use it is the files folder that I showed you in my drive gets attached to this app, and then I can browse all my files and folders there. So if I go to this URL, I can get to my own cloud instance, and I don't have any sort of SSO setup at this point. You saw that I'm still working on it here on the RBAC molecule. So I just use the default credentials to log in. And here you see these three folders. I don't want to actually get into those folders, but what I can show you is inside the files folder, you see OnCloud as a user, and then each user will have its own file, so that can be separated. And these are the three folders that you saw on the app here. So these ones. And now what I can do is I can use this as the platform to share files with other users on my network. At this point, you saw there's only one OnCloud user, but I'm adding SSO support pretty soon. So other family members can add their files, and they can even create URLs to share them. So all of that will be within my own Homelab setup. The second app that I want to show, which uses persistence, is pretty obvious. It's a database, and in my case, it's a PostgreSQL server. So I'm going to be storing some app data on my payables app. So this app, sort of a bill management app, and then internally parses my credit card stuff. And each of these microservices internally have data storage, and I want to store those app data in my Postgres server. So if I show you the molecule again, here I set a Postgres, and I'm just using the Bitnami Helm chart. And the way I've configured this is again via values.yml. This is the default one that comes with the Bitnami Helm chart. And the major parts that I've updated is the persistence block. As you can see here, I've enabled it, and it's using an existing claim. What I noticed is most of these open source Helm charts on the internet have a similar structure, and they allow you to pass in an existing claim, which is a persistent volume claim, and otherwise it can create its own. But I want to have a very specific set of attributes on that PVC, so I used my own existing claim. And the storage class that OpenEBS creates is this one called OpenEBS host path. So let's actually get into the cluster and see what's going on. So the first thing that I'll show you is the persistent volume itself. Or actually, let's go to the storage class first. There are these three provisioners. The first storage class was created by the K3s server itself, which also had local path available, but I didn't want to use it because I didn't want to depend on what sort of cluster you set up. In case somebody sets up their cluster using kubeadm, this won't be available. So I want to have a level playing field for any of the cluster setups. So OpenEBS created these two provisioners, and I want to mostly focus on the OpenEBS host path. And if you take a look at the value that I passed in for base path, again shows up here. And what that means is now I can create persistent volumes with this storage class. And then when I pass in a sub path, it will use the same hard drive. And then within that hard drive, there are separate folders for each volume. If I go back to the PV again, I've created two main PVs on this OpenEBS host path storage class. The first one being the largest one, which is that files folder that OnCloud uses. So it's actually 1.8 TB bytes. And if you take a look at this, this is created actually using a local Helm chart that I created, which is this one. And what internally it lets you do is create a PV and optionally PVC as well. So if you look at the volume, what it does is all of these are actually sort of parameterized, but one thing that I didn't want to change is the persistent volume reclaim policy. So in case the PV gets deleted by accident, the backing data, which is actually backed by the host path storage class, the local provisioner that OpenEBS created, that gets still retained. So the data won't get lost. But what that means is you can be assured that you can still delete the PV and the PVC off your cluster, but the data won't disappear. So just a sort of precaution that I wanted to add. The second part of this Helm chart is the PVC itself. So when I showed you the Postgres application, it used this existing PVC. So how I've set that up is here I use that Helm chart to create my PV, and then you see this node affinity, and then that means this PV can only be created on this node, which is what I want again. So that's fine. And then the PVC that's going to get attached to this volume has this name. That's it. And then what I do is just I pass the same in the values.yml for Postgres that I showed before, which is here. PVC, this one. And if I show you the Terraform for this, in the PostgreSQL Helm release for the PV and the PVC, I've added the lifecycle to prevent destroys. So even if you accidentally try to delete it using Terraform, it will not let you do it, and you're going to have to sort of comment this out and delete it. So just again another set of precaution to not let you delete your data by accident. So these are the two main applications that are currently using the OpenEBS host path storage class. A couple of things are in progress. One is I actually wanted to set up MongoDB as well, but I have a couple of issues on the ARM architecture side, so need to figure that out. The third part is the RBAC that I want to set up using the SSO, and the SSO that I want to use is Keycloak. And once I've set up Keycloak, I want to create users for each of my family members, and they just can use the SSO to log in on OnCloud and any other applications that I install going ahead. I want to add SSO integration to pay your bills as well. That'll be great. That kind of covers everything that I've done for storage at this point, and I hope that ignites curiosity in you to try this out as well. Feel free to add your questions about what sort of storage solutions that you would want in your Homelab setup, and I'll be happy to discuss that in a future video. See you in the next one.